Welcome back to The Explainer. We're diving right into episode 6.5, part 2 of our look at the full marine generator testing suite. Today we're talking about special tests, which are basically on-request verification. Think of this as walking right past the general admission line and stepping straight into the elite VIP room of marine engineering. We are looking at tests that don't just happen on a typical Tuesday on the factory floor. No, these are the deep, highly diagnostic evaluations reserved for when the stakes are at their absolute highest.
So, to set the stage, let's contrast our baseline with what we're actually covering today. In our last explainer, we looked at the mandatory standard factory tests, the routine tests that literally every single machine gets, and the type tests that prove the design on the very first unit of a series. But today's tests? These are on request. They are exclusive, they're highly specific, and honestly, they only happen when a buyer or an engineer explicitly asks for them and, of course, pays for them.
Section 1. The 7-item forensic toolkit.
I want you to think of this as an a la carte menu of forensic tools. We've got 7 specific special tests here, complete with their industrial codes. We're looking at sound level measurement per ISO 3744, sudden short circuit testing per IEC 43-4 or IEEE 115, shaft voltage measurement, waveform measurement, load switching on and off, starting the synchronous motor under a locked rotor, and the polarization index or PI per IEEE 43. Phew, that's a lot, right? But remember, this isn't your everyday checklist. These are the heavy-duty tools engineers pull out only when they need a really deep, uncompromising look at a machine's capabilities.
Section 2. The hidden killer, shaft voltage measurement. Okay, let's dive into this. I want you to put your forensic detective hat on for a second. Imagine you've got this beautifully constructed synchronous machine spinning flawlessly, just humming along. But underneath that perfection, there's an invisible electrical current slowly, silently eating away at the hardware. So what exact test acts as an early warning system for this invisible, bearing current damage?
Well, the answer is shaft voltage measurement. It's a diagnostic check that directly predicts the risk of bearing current damage. By taking a probe and reading the voltage difference between the rotating shaft and the stationary frame, engineers get a crystal clear window into the health of the machine's internal electrical isolation. It acts as an early warning system, specifically for the insulated N-end bearing, the non-drive end bearing we talked about before.
The stakes here are absolutely crucial. Standard construction uses that electrically insulated end bearing to prevent damaging shaft currents from circulating and pitting the bearing surface over time. So, if a shaft voltage measurement returns a higher than expected reading, it means that critical insulated bearing barrier might already be compromised. Actually, scratch that, it's a massive red flag that a hidden killer is already loose in the system.
Moving on to Section 3, the used car inspection, also known as the polarization index.
Think of this next test like bringing a trusted, top-tier mechanic to inspect a used car before you hand over a massive check. Imagine you're part of a high-stakes secondary market transaction. Your client is about to buy a multi-million-dollar used marine generator, and they specifically demand polarization index testing per IEEE 43 before signing anything. What exactly are they checking for, and why is it worth the extra cash?
Basically, they're checking the machine's hidden history. The polarization index, or PI test, evaluates the overall insulation health and moisture content deep within the winding insulation over a specific period of time. It acts like a really deep mechanical inspection. It reveals whether the machine has been stored safely or if it's been sitting idle in some humid, tropical environment, just soaking up moisture that could cause a catastrophic failure down the line.
And this brilliantly illustrates the 2 potential outcomes. As the PI test runs, it continuously watches the resistance ratio. A rising resistance ratio over time, that indicates dry, healthy insulation. It means the financial risk is low and the machine is structurally sound. But a flat or falling ratio? No way. That flags serious contamination or moisture ingress. It tells the buyer the windings are compromised, ultimately saving them from buying a machine that might just short out the very first time it's put under a heavy load.
All right, Section 4, the complete marine generator testing suite. Let's put all the pieces of the puzzle together.
We can now perfectly organize this whole complex testing ecosystem. You might have come into this explainer series only vaguely knowing that testing existed, but now you can clearly distinguish the entire 3-tier framework. You know that routine tests happen on every single unit involving 11 standard baseline checks. You know that type tests, like the IEC 34-1 heat run, apply only to the first of series to prove the core design.
And you now know the special tests, those 7 on-request forensic tools, like shaft voltage and the polarization index, used for used market verification and deep diagnostics. You officially have a principal engineer grasp on the whole shebang.
But hey, our journey through marine engineering doesn't stop here. Up to this point, everything we've covered has focused on the power plant itself, right? The switchboards, the breakers, the massive generators. We've completely mastered how the power is created and tested. Now it is time to head aft, all the way back to the stern, and look at the actual hardware that pushes the ship through the water. Which leaves us with this final burning question to ponder. We've mastered how to generate massive amounts of electrical power, securely and safely. But how exactly do we take that raw power, step it outside the ship's hull, and turn it into 360-degree steerable thrust out in the middle of the ocean? Join me in our next explainer as we unlock the secrets of the Azipod propulsion system. Trust me, you are not going to want to miss it.